static RAM using DSCH or Microwind. I will explain about that. This is the static RAM using 6 transistors. There are 2 PMOS transistors are required, remaining 4 are NMOS transistor. So we need to take Q bar means that is the output, and BL bar and BL and WL are the inputs. So for this, first need to open, that is DSCH 3.9. First open the DSCH 3.9. So then go to file, and select foundry. Go to file, select foundry and 45 nanometer technology. If you want, you can change one more also you can use. And we know that 2 people on right side there is options, as you know. So take the transistors one by one and click on that and place it here one by one. And if you want to shift, you can shift the components. And if you want to move, the move option is there in the top side, and one by one. So like this, we need to place the transistors first as per the circuit. 6 transistors, 4 are NMOS and 2 are PMOS transistor. After this, click on the wire option is there. Wire option is there. So click on that and give the connections properly. Click on the wire option and give the, this is the wire option. So click on that and give the connections properly one by one. So I am giving the connections one by one. I am giving here. So I am giving, of course supply is required, and 2 Q bar and Q is required. Take the supply and VDD, ground and VDD. So BL is required, BL bar, and use 2 outputs, Q bar. Q bar is required, and Q bar is required. So double click on that. If you want to change the names, you can change instead of output to. So just I am giving Q bar. So total connection is completed. Of course, here also one more input BL is required. BL and BL bar is required. So now the total circuit is connected properly. Then we need to run. There in the top side there is an option is there, that is run option. So click on that and check the different cases output, when WL equal to 0 and BL equal to 0, or when W equal to 1 and BL equal to 1. So in different cases we need to observe the input and outputs for the static 6 transistors RAM. So after this, so you can check it. After click on the run option, there is a green option is there, green button. So green button is there. So click on that, and in different cases BL should be 1 or 0, BL and WL. So in that cases, what is Q and what is Q bar outputs you need to observe. So in different, after this, after run option, we need to go for, that is timing diagram, then close it. So this is the timing diagram. There is a top side red lines are there, that is the timing diagram option. So click on that, you may get the, that is outputs. Then after this, go to file, this is the important step. Truth table also you can get it from the simulation. So we will get the truth table output also. Then close on it, then file, and make a save as static RAM. I am saving any folder, you can save it, don't worry. So in my folder I am saving in a documents, and in that Raju sir folder is there. So from there I am saving. Then so we need to go for, that is we need to open, that is backend designing backend. So for that we need to open, minimize it, and we need to open. Before that so it should be, make it as Verilog file. Go to and make a Verilog file. Go to file and make a Verilog file option is there. Click on that, then we'll get this one, and update Verilog. Click on update Verilog and click on OK. Now we can minimize it, and to design backend, go for Microwind. Open Microwind, then click on OK. Then file, select foundry and select the 45 nanometer technology. So compile, go to compile Verilog and extract your file from the documents. For example, in the documents I need to open my project, that is static RAM. So compile, click on compile and should get 0 errors. Then click on back to editor. So you may get the mask layout diagram, QQ bar and BL, when BL is equal to 0 and WL equal to 0, what is the output. So like this we need to observe the outputs, and these are the diagrams. Mask layout diagram. Green color indicates, that is N diffusion, red color indicate polysilicon material, and blue for metal. So after this you can see the 3D diagram also. In the top side there is a 3D option is there, 3D. So click on that, you may get the 3D option. So then close it. Again we need to go for, so if you want to unhide, you can unhide. If you want to hide, you can hide. So after this we need to go for, in the 3D option side there is one more option is there. After 3D there is one more option, that is step by step process. Click on that and then go for that is thin oxide growth, thin oxide indications and gate areas, N plus implant, P plus implant. Like this, if you take any design, you can easily observe that using Microwind. Thank you.